Hey guys, this is Fred from Pretty Fly Games, and today we're gonna build a car AI in Unity. So in Unity I've started up our top-down car controller that we built before, and what we're gonna do is we're gonna replace the player's input with AI input. That way we will have an AI that doesn't cheat. It has the same parameters and restrictions as the player, and that's what I like in games, when the AI is not cheating. And I built a little course here based on Kenny assets, which are freely downloadable from the internet, and they are great to create prototypes and games with. So we're gonna start with our car player that I've created a prefab from, and I've assigned a tag called player. Now the easiest way to create the AI is to duplicate this, and we will change it into AI player, and we will give it a tag AI. Then we will change the sprite into car blue instead, so we can separate them, and then we will create it as a prefab instance, a variant, because we want to base it basically on the player's code, so we can leave it as that. And what we will do is we will open our prefab, and the difference is that we're gonna remove the car input handler. So let's get rid of that, and let's save the AI. If we run the game now, we can basically drive around with our own car, but nothing happens with the AI as we haven't programmed that yet. So let's get started with that. So let's create a script for that. I'm going to call it car AI handler, and let's assign that to the AI player. And then we open it in the Visual Studio. So what we're gonna need is a reference to our top-down car controller, so we can apply the input from the AI to that. And we use the awake function like before to get a reference to that. Then we want to have some possibilities to control the AI, or to have different variants of the AI, and we're going to build a few. We're going to start with basically AI that can chase the player, and then we will build a waypoint system AI that follows waypoints. So we will create a few enums for that, and it's going to be follow player or follow waypoints. And what we want is we want to have the ability to change the settings for this. So we will add that so it becomes available in the inspector, that you can change the AI mode basically. Then we will need some local variables as well to be able to basically steer the AI in the correct directions. So we will have a target position and a target transform. The target transform is used when we are basically chasing the AI or chasing the player, and the target position is used when we are following waypoints and other things. So that's great. Now what we want to do is we want to change the update here to the fixed update instead, because it doesn't need to run at every single update frame. It's enough that it runs on every physical frame, so that conserves a little bit power from the program if we're going to run a lot of AI opponents basically. Now what we want to do is we want to have our input vector, and what we want to do is basically apply or set the input vector based on the AI's input into the top-down car controller. So if we put the input vector on the x-axis to be, let's say, 1.0, and the input vector on the y-axis as 1.0, it means that the car will turn and accelerate at maximum speed all the time. So if we save this and run the script, now the car AI should basically be moving. Okay, so now we created a basic car AI that just turns around and accelerates. So great, we're done. No, just kidding. We're gonna make this a lot more interesting and with the ability to chase the player. So let's go back into Visual Studio again. So let's get rid of our automatic throttling or acceleration and turning. And we're gonna replace it with a switch statement. And the switch statement basically looks into the AI mode and handles it dependent on what it's set to. It's like an if statement in a way, but it's easier to maintain better code, or at least I think so. So let's make a case for the follow player, and we will create a function called follow player. And the follow player basically will be a function that looks at the target, and if the target is null, we need to acquire a target. And what we will do is basically we will look at all the game objects with the tag players and get them and assign them to the transform. Now it could be that there are no players around, so we added just a check that we really got something back, so we make sure that it's still not null, and then we assigned the position of the target as the target position. Now that we basically run the scripts, it will basically the target transform will be null, and it will find the player, and then it will get its position. Now, based on that, we also need a way to turn towards our target position. So we will create a function for that as well, called turn towards target. And what it will do is basically it will calculate a vector to the target. So it will take the target's position minus the transform's position, and that will result in a vector. What we need to do though is we need to normalize it so it becomes between 0 and 1 instead of a very large number basically. So this will give us the direction towards the target that we can use. And what we want to do is we want to calculate an angle towards the target so that we know where it is basically. And what we do is we use the vector2 signed. So we use the vector2 signed angle, transform up, and the vector to the target, and that gives us a signed angle. Now what we need to do is basically we want to just invert it, so we get basically the inversion of this function. It gives the angle the car needs to steer in to reach the target. So what we want to do is we want to turn towards this angle, but we want to clamp it down into something that is more manageable, and we want the car basically to steer a lot if the difference is very large and steer very little if we're close to it. This will reduce jittering when the AI is trying to steer towards the target. So what we do is we create another variable, steer amount, and we take the angle to target and we divide it by 45. So if it's larger than 45 degrees, it's still gonna be like a maximum. So this is something that you can adapt the values to fit your own project, but 45 is a quite good value for this type of top-down racers. Now what we want to do is, as well as I said, we want to clamp it so it fits the steering function, which expect a value to be between -1 and 1. And then we basically will return this. Now we need to start using this function as well for it to actually work. So in the follow, or actually we will make it here so it becomes available for not only when you follow the player, but also when you race towards waypoints. So we will take our input vector .x and say that it's going to use the function turn towards target, and we're going to apply maximum acceleration all the time. So now hopefully it should follow the player around and just try to reach the player, and that's it. So let's try it in Unity. So before we test the code, let's reduce the sound of the cars because it's driving me a little bit crazy. And since we used the mixers before, we can just reduce the master volume to something like -21. Now, let's go back and take our AI for a spin. And now we have an AI controller that chases the car. And this is similar to what we have done actually in Total Arcade Racing in survival mode. So now you have the recipe to create a game such as that. And of course you can spawn as many AI cars as you want. The next part that we're going to look into is how to get the AI car to basically follow the path of the course instead of just driving around like crazy. So we're going to create a waypoint system. And before we start with that, I'm going to just show a little bit what a waypoint system is. And also we are not going to make a proper waypoint system. We're going to make something called a node system instead, which I think is a lot better. So let's cover what the difference is between waypoints and nodes. So here's an illustration of our game, and we have our AI car up here. And in a waypoint system, you would basically drive from one point into another, and we then add a section or points, and eventually we make a full course out of it. Now, the problem with this type of system is that it does not cover this part. So if we want to build a waypoint system that also covers this part, we need to create another waypoint that goes in through here and around. And if you create a game like a city type of racing game where you have lots of streets with intersections and things like that, you will have a nightmare getting the waypoint system to work. So instead, what we're going to do is we're going to change this into a node system. And the difference is that one node can have many sort of ways to exit from. So if the AI drives here, it now has the ability to turn left or turn right actually, or go straight ahead. And by building this system, we can basically handle intersections in a much easier way, and it becomes easy to make different alternate paths in the waypoints. So that's what we're going to do in Unity now. So this is going to be a very simple script. So let's start by deleting basically all the functions, and we just need some public variables. So what we will have is a public variable that takes in the next node that we're going to use, so that we can tell this waypoint which nodes it's connected to. And then we will also add another variable, a public variable, called min distance to reach waypoint. So we want a certain distance that the AI car is driving towards, and when it has hit this distance, then it basically has reached the waypoint and will go towards the next one. So let's save that and hook up the waypoints in Visual or in Unity. Now, like a good chef, I already prepared a script that will draw basically our waypoints so we can see them. And let's connect the different nodes. So we create one node here and we attach the next one. Now we get the blue line that shows that it's connected. And then we do the same for the others. All right. and then the last one we will connect it to the first one, so we get a closed loop like that. Now I will spend some time to just fix this path so it aligns with the course. Give me a minute for that. Okay, so now I created the different waypoints. The only one that is left is this that I called split. So we will make the size 2 of the array and connect it to the fourth one, which is this one. So we'll drag that in there, and then we get this nice intersection here. And now we need to go back into Visual Studio and change the car AI script so it can drive along the waypoints. So we're going to add a few more local variables. The first one is that we need to keep track of what our current waypoint is, the one that we are currently driving towards. And then we also will need a list of all the waypoints so that we know where all of them are, and we will need this later on. So when we go into the wake function, we want to collect all the waypoints. So we find all objects of type waypoint node. That gives us an array with all of them, and we do this in the wake, so we cache them so we don't do it all the time because it takes a little bit performance. Then we will go into our AI mode, and we will add the case in the switch statement to handle the possibility to follow waypoints. And we will create a new function for that, and it will be called follow waypoints. And in the follow waypoint, we can add it below here, like so. The first thing we need to do is basically pick a waypoint if we don't have one selected, similar to what we did with the target when we're chasing the player. So first of all, we will check if the current waypoint is null, and in that case we will use a new function called find closest waypoint that we haven't created yet. So let's create that one first, and it will be a simple support function basically, and it returns a waypoint node. And what we do is we take these all waypoints that we already had, and then we use a link statement to order it to find the closest one to the actual AI. And what we do is use the order by, and then a lambda expression. T is just any name. T is just a default value. You can use A, B, X or whatever you want, but we use a T as in transform. And then we check the distance from R, the AI's position, to the T, basically the one in the array. And what we wanted to do is return the first value it finds. So we use first or default. And let's just tidy it up a little bit. And the reason why it's red is because we need to include a link in this. So let's go to the top of the script and add using system.link. Now, that was a mistake. So now all the errors are fixed. And if we don't have the closest waypoint, then it will pick the closest one to the AI. So that's all good. What we then want to do is we want to basically tell the car to drive towards the current waypoint. So if the script for some reason, or if the scene for some reason don't include any waypoints, we'll just check that it's not null. And if it's not, then we will set our target position to the current waypoint transform's position. So it will drive towards the waypoint. Now, what we want to do is when we are close enough to the waypoint, we want to start to follow the next waypoint. So we will do a distance check, and what we do is we subtract the target's position minus the waypoint's position, and we check the magnitude. How far away is it? And we added a variable to our waypoint node that allows us to dynamically check how close it is. So we'll add this. If it is below or equal to the minimum distance of the waypoint, then we will basically pick the next one. And how we do that is basically we will look at the current waypoint, and in it there is an array called next waypoint node, and we will pick, let me just fix these errors. We will pick in the array a random value between 0, which is the first element, and the length of the waypoint. So this will cause it to basically, if there's just one option, then it will go to the next one. But if there are 2 or 3 options, then it will randomly pick between these 3 and then follow along that path, basically. So if we try our script now, it should hopefully follow the waypoints. So let's see if it works. So in the AI player, let's change the AI mode to follow waypoints instead and press play. And hopefully it will start to follow the waypoints. And well, there we go. Now it tries its best to follow the waypoints. And as you see, it's not perfect. It sort of misses the waypoints. We can have a look at the scene instead, so we can see how it actually tries to reach the waypoints. Now, the reason why it's not hitting the waypoints straight on is that the AI is driving at full speed all the time. So it's never trying to brake, it's never trying to adapt its speed based on how much it needs to turn. So let's go back into the code and correct that and add some more smart things into the steering behavior. So what we'll do is basically look at the code, and this is what is causing it to accelerate at full speed all the time. We will replace that and basically create a new function called apply throttle or brake, like that. And we need to create that function as well, and we'll add it at the bottom. All right, so what we will do is make it quite easy. We will actually add another value into it. We will add how much the car is turning. So let's feed that into the function. So we will take how much the AI wants to steer the car to the side, and we use that as an input into our function. Now what we will do is we will apply the throttle based on how much how much the AI does not want to turn. So if the AI wants to turn a lot, then we will not apply that much speed forward. If the AI wants to go straight ahead, then we'll just floor it. So what we will do is basically make a little bit of a math function where we look at the absolute value of the input, and we will divide it by 1.0. So that gives us a range between 0 and 1.0. Then we take our default value that we want to use, 1.05, and we take away this steering. So if the player is steering maximum to the side, then the throttle will just be 0.5. So we will always have a little bit throttle forward. So let's take this for a spin and see how it behaves in Unity. Alright, so let's see if it behaves better. We can see that it slows down when it turns a lot, and it still has some problems hitting some of the waypoints, so it still needs some assistance to actually navigate this course properly. And we will sort of make the AI a little bit more smart by giving it some hints on what it should do. So we will enhance our Waypoint node system to actually have another variable called maximum velocity or maximum speed, which sets how fast the car is allowed when it's driving through certain parts of the course. So let's add that into our Waypoint node system. So let's open the Waypoint node script in Visual Studio, and we will add this parameter max speed that is set once we've reached the waypoint. And we'll go into our car AI handler, and we will look at the apply throttle script, and here is where we want to handle that it's traveling at a certain speed. So before we do that, however, we need to add a variable called maximum speed. So we will add that as a setting to the AI max speed, which is 16. And then in this function apply throttle or brake, we want to add a check. If we are going too fast, then we essentially do not want to increase the speed any further. So we'll take the top-down car controller, check how fast we're going, and if it's above maximum speed, then we return 0, which is basically that it will not accelerate any further. Then we also need to set the max distance based on the node. So if we look at our current waypoint, and when we have reached a new waypoint here, we can check that if the current waypoint's maximum speed is bigger than 0, then we will assign the max speed as that. Otherwise, we will just pick a really big number, like 1,000, and let the car drive as fast as possible, because we don't want to have well, the requirement to set the maximum speed for each and every waypoint. So if it's just 0, then we put it to a very high number, so the car will travel at maximum speed. Okay, so let's adapt our things in Unity and see how the car behaves. Okay, so in Unity, let's apply the various max speeds. So in these corners, I think it's okay. When it reaches this point, we want it to reduce the max speed to, maybe we can try it 8. And here we can have 7. And on this part, I think we can allow it to throttle up a bit to 10 maybe. And here we reduce it to 8 again and 8. And then it can throttle up again. So let's see how those values work. And we'll go into the scene view. So now it reduced the speed, and well, maybe a little bit too much. So let's tweak the values a little bit and see how it works after I tweak the values. I'll be right back. Okay, so now I've tweaked the values and I've added a few more cars to make it a little bit more interesting. And as you can see, they are behaving a lot better. And can sort of handle the course without going too far outside of it. Well, except for when they're pushing each other like that. So in the next video, we're gonna look at some avoidance parts, so the car can overtake each other and also avoid each other instead of just bumping into each other. So I hope that you've enjoyed this video so far, and hit that subscribe button and also the bell to get a notification when the next video is out. Here's an example from our game, Total Arcade Racing, which uses this component for its physics. You can find the game on Steam and take it for a spin if you want to. Thanks for watching the video, and I hope that you enjoyed it.